Hello students, welcome to my YouTube channel Data Shah. In the last lecture we have learnt about Big M method. In this lecture also we will be doing one more example of Big M method. So let us consider the example. This is a word problem. So first we have to convert it into the LPP form. So consider food X contains 6 units of vitamin A per gram and 7 units of vitamin B per gram and costs 12 paisa per gram. Food Y contains 8 units of vitamin A per gram and 12 units of vitamin B per gram, and that costs 20 paisa per gram. So the daily consumption, now the daily minimum requirements of the vitamins and vitamin B are given as 100 units. Minimum requirements are given, that means you can consume more than that as well, and 120 units of vitamin B respectively. So find the minimum cost of the product mix problem by the simplex method. So it will not be given, sometimes it is given that you have to solve with the Big M method or the chance method. It is also known as, the other name is chance M method. So it could be given, otherwise this is how the word problems are given. So let us formulate the solution first of all. So the solution that we'll be having would be, first of all, let us formulate the LPP. So let X1 be the grams of food X and X2 be the grams of food of Y that is purchased. So the problem can be is always like your X1 and X2 have to be greater than equal to 0. So that's the non-negativity constraints because they are in grams. So now here we'll be formulating our linear programming problem. So the linear programming problem, as you could see here, they are asking us that the minimum requirements of vitamin A and vitamin B are 100 units and 120 units, and 6 units per gram we require, and this is of vitamin A, 7 units of vitamin B for the food X, and 8 units of vitamin A and 12 units of vitamin B for food Y. So the constraints are given to us. The constraints would be 6x1 because this is for the food X we are talking about. So 6 units of vitamin A and 7 units of vitamin B. So this is what we'll be having, and let us just formulate. Okay, now find the minimum cost of the product mix. So the minimum cost would be, now this is the cost which is given to us per gram. So we'll be taking it per gram. So we'll be calculating it in paisa, and let us write down. So minimum cost, so minimize Z is equal to 12 paisa per gram of food X, 20 paisa per gram of food Y, subject to the constraints. Now, as you would notice here, we are talking about 6 units of vitamin A in this, and 8 units of vitamin A per gram, and this is the total quantity, 100 units of vitamin A minimum, sorry, and it could be greater than that also. So I'll be just formulating this as 6x1 plus 8x2 greater than equal to 100. Similarly, for the vitamin B, it would be 7x1 plus 12x2 greater than equal to 120, right? And lastly, x1 and x2 both are greater than equal to 0. So the LPP is given by this. Now here, as we know, we have to solve it by simplex method. So in the simplex method, whenever we have greater than equal to type, so we'll be subtracting the surplus variables and we'll be adding the artificial variables. So now it's our choice. Either you can use the two-phase method or the big M method. So as I'm doing the big M method, you can also apply two-phase method here, and you can solve the answer, would be the same. So let us just convert it into the maximization type first of all. So this would be maximize Z dash, where your Z dash is minus of Z. So this would be minus 12x1 minus 20x2, and subject to the constraints. So 6x1 plus 8x2 minus S1 plus A1, that would be equal to 100. 7x1 plus 12x2 minus S2 plus A2, that would be equal to 120. So both are the surplus variables. So because I have converted into maximization, so now it would be plus MA1. We are talking about this would be MA1, sorry, that's the negative again, minus MA1 and minus MA2. So this is what we have got here. So now x1, x2, your S1, S2, A1, A2 are all greater than equal to 0. So what is the basic solution that we are getting? This is our second step. So basic solution is nothing but A1 is equal to 100 and A2 is equal to 100, and these are the basic variables, and rest all the 4 variables are the non-basic variables. So let's quickly move to the initial table that we have. So this is the initial table, and here the Cj that we are having is this was minus 2 minus 1 0, this is minus m 0 minus m. So it's your choice whether you want to write S1 S2 together and A1 A2 together. That's your choice. So this is minus m, their cost is 100 and 120. So quickly fill in the boxes here, and we are getting it as 6 7 8 12 minus 1 1 0 0 0 minus 1 0 1. So our Z dash is minus 220m, and Zj we'll be calculating, and delta j is nothing but Zj minus Cj. So this would be minus 6m minus 7m, that's minus 13m. So that becomes 2 minus 13m, right? And this is 8 minus 20m. So this is 1 minus 20m. So you could easily identify what would be the value that we could be having here. So this is plus m, this is m minus 0, this is minus m, this is 0, this is again plus m, this is minus m, and this is 0. So this is the most negative that we are having here, 1 minus 20, because it's the minus 20 that we have along with this. So this would be the most negative. So this is the entering variable. Now to decide using the minimum ratio, the leaving variable, it would be 100 divided by 8 and 120 divided by 12. So that's 10, and 100 divided by 8 we could quickly calculate, that's 120, it would be 12 point something. So that's obviously this would be the leaving variable. So this is our pivot element. easily we could identify that A2 will leave and X2 will enter the basis. So A1 as it is, this is X2. So X2 cost is -1, this is minus M. Now we have to make it 1. So I have to divide the whole row by 12. So this becomes 10. 7 by 12, 0, 0, minus 1 by 12, 1 by 12. So that was very easy. Row 1 minus 8 times of row 2 because I have to make it 0. So 100 minus 80 is 20, and 6 minus 6 minus, let me just quickly do it, 8 7s are 56 by 12, so that's 72. So 72 minus 56 would give me 12 by 12. That's I'm getting it as need to calculate it. Okay, sorry, this is not 56. Let me just quickly. So that would be minus 8 times, so that would be 6 minus 7 by 12 into 8. So 2, this is 3, 3 6 are 18 minus 14, so that's 4 by 3. And this would be minus 1, 1, that's 0 plus 8 by 12, so that's 2 by 3. This is minus 2 by 3, right? So now when we'll calculate z dash would be equal to that's minus 10 minus 20m, and zj and delta j we can calculate. So that would be equal to, zj is coming out to be minus 7 by 12 and minus 4 by 3m, that's minus 1, so this becomes 0. So when you will add plus 2, so this would be 24. So 24 minus 7 is we will get it as, so that would be minus 4 by 3m, and this would be plus 24 minus 17 by 3. So this would be the larger quantity. So that now this would be the entering variable, obviously, and this would be zj. Quickly I'll just write m minus m. This would be m, this is 0, this is again 0, this is the second artificial variable is of no use actually, but still if you want to calculate, you can calculate it. This will be getting it as 1 by 12 plus minus 1 by 12 plus 2 by 3m, so that's positive, and this is plus 1 by 12 minus 2 by 3m. So ultimately, obviously, minus 4 by 3m is the most negative, so we'll be just entering it. So this will enter, and the leaving variable we could easily decide. So it's 5 3s are 15, that we are getting 20 upon 4 by 3, and this would be 10 upon 4 by 3, and this would be 10 upon 7 by 12, so that's 120 by 7, and that would be just 15. So this would be the leaving variable, sorry, and this is the entering variable. So this would be the pivot element that we have. So okay, so I have just missed the another table, so let me just do it here only, and when you will see, this would be just we'll be having here x1 and x2. So the cost is minus 2 minus 1. I have to make it 1 throughout, so this would be 20 divided by 4. I will be getting here 15 only because we have calculated, that's the same thing. So this would be divided by 0. This would be artificial variable is of no use, but still if you want to calculate, this would be minus 3 by 4 because we are dividing the whole equation by 3 by 4 times r1, so that we can cancel it out. This would be 3 by 4. This would be just half. This would be minus half, and this is what we are having. So next we'll be having this, so I'll have to reduce this equal to 0. So r2 would be r2 minus 7 by 12 r1. So to make it 0, this is what we have. This is ultimately I am getting it as 5 by 4. This would be 1. This is 7 by 16. There's no need of calculating them, so this would be minus 3 by 4. So this is what we are getting. So calculating z dash is minus 205, and zj is minus 2, minus 1, delta j is 0, 0. So this is 7 by, this is, I'm getting it as 3 by 2 plus 7 by 16 minus 7 by 16. And this would be, no need to calculate them as well. So this would be minus 1 plus 3 by 4. And when you will calculate, this would be 8 3s are 24. 24 minus 14 by 16. And this would be again when you will calculate this, this would be 1 by 4. So as all the delta j's that we are having here is greater than equal to 0, so as the delta j's are all greater than equal to 0, so the optimal solution is obtained, and the optimal solution is given by x1 is 15 and x2 is 5 by 4. So that means 15 grams of food X and 5/4 grams of food Y is what we require, and the maximized Z dash was minus 205. So minimum Z would be 205. So this is our minimum cost, and the minimum cost is achieved when we are taking 15 grams of food X and 5/4 grams of food Y. So this is the last example for the Big M method.